Okay, welcome, students, teachers, onlookers, to this video lecture. Today I'm going to go over some code. This is some old code. I'm showing it to you now, and then I'm going to clean it up within the next few days, and then come back and show it to you looking better. But we can kind of use this as what not to do, or how can we improve. So first, let me run, because like I encourage all my students, it's best to run the program first to show people what you're talking about, and then show the code, because it's easier to give, because most people are visual, right? Because most of us think in pictures versus words. So when you can see something happen, or we see the event and then we piece it together from there, and then we break it down. Like, for example, you used the TV before you probably ever popped one open, or you owned a computer or a phone before you ever popped one open. So you usually understand things from the outside in versus the inside out, right? So it's always good to show the program running. So as I'm doing that, let me go ahead and get it running. And then I need to change views as per Zoom. All right. So yeah, I should be able to see that. Let me blow this up a little bit. Okay. So what do I have? I have a word search game. It's in developer mode. It's in more of like a test debug mode, where I'm printing out all this extra information that I don't need. Okay. Or that's for the developer to kind of test, make sure it's working. And so what I have is a list of, and you'll see it in the code, but a brief breakdown. I have a list of words. Okay. And I create a board, and I shuffle the words, as many words as I can on the board, based on the size. Right now, I'm only choosing one size, so I'll have the ability to choose multiple sides later. So that will be something that we should write down: multiple sides, okay, versus one side. I do scramble the words as per word search, which means it could either go left to right, right to left, top to bottom, bottom to top, and the diagonal, either way, criss or cross, however you want to look at that. Okay. The words that got on the board have coordinates related to them. Okay. As you can see. Uh, the words that aren't on the board won't have any coordinates to them. So like salad, sandwich, spinach, tomatoes, or tomato, whatever that says. I spelled that wrong, but anyways, tomato, walnut is not on the board. Okay. And the words that are on the board, like say, have a coordinate: apple, banana, carrot, egg. One thing it does look like I'm doing is I'm putting the words in order each and every time. So I'm going to add in a shuffle function. I'm going to add in a formal greeting. Obviously, I'm going to take away this debug output that no one needs, that the user does not need, would probably be distracting. Okay. Now, the way this works, because it's console, and I also need to have a welcome and then some instructions. Right now, I just have please enter a set of coordinates, press enter to continue. I probably should have please enter set of coordinates, and then press enter, and then press enter. So better instructions. I'm going to put this on a grid so they can see the numbers, like 0 to 9 at the top, 0 to 9 on the side. So I'm going to do that just to make it look nicer. And then I'm probably going to add in color. So the way the game works basically is you have to put in the coordinates of the word. So if you can see right here at this top corner is the word T, okay? And so if you see TORRAC, well, that's carrot backwards. So that is carrot, and I believe that's found here, and there it is on the board, 0, 0. Okay. I think it says 8, 0. Yeah, 0, 0. Let me blow that up just a little bit. See, my eight's better. So this one's at 0, 0. Banana is at 8, 0. And apple is at 8, 0 as well. So we can go to 8, 0 and see that you'll notice there's a banana and there's a apple. So if I go to 8, 0, I'll see apple, APPLE, right? There it is. And then I'm also supposed to see banana somewhere in here. Don't see it, but we'll work on highlighting in colors when we do it. So right now, if you see found is false, found meaning the user has not put in the input. So because it's in developer mode, you can come right here, select it, and then you will, okay, so banana was supposed to be diagonal. So you can select it, and then it'll go from found false to found true. And I didn't see banana because it was diagonal. So the orientation right now is the number, but it coordinates to top to bottom, bottom to top, left to right, right to left, and then diagonal. So I'm going to put in a better interpretation of the orientation so you know if it's going up and down, left or right, or diagonal. Okay. And now we should be able to go back and we see banana. There it is. BANANA. There's banana, and then there's apple, there's carrot. So let's say I found apple and I put in the coordinates directly. So what you can do, because it's in developer mode, is you can copy this by highlighting, control copy, come here, control V. Now when you hit enter, it's going to repaint it. Now when I hit enter, okay, looks the same. So it'd be nice if we highlight that. But if you can go to Apple, you'll notice it's now found. Oops, I put in the word Apple. Okay, it didn't find it. I might have put in the wrong one. Let's try another one. Let's try carrot. Because it should have said found equals false. Let me try carrot. And if not, that's another bug I need to go fix. Okay. Control copy. Control V. Okay, let's see how that works. See if that works. So it's not finding them for some reason. So that definitely is a fix that needs to take place. And it's probably because it's not in the correct order or something else. Okay. So that I definitely need to work on. Okay. Several things I need to work on. Oh no, sorry, it is. There it is. Carrot found equals true. So it did work. Found equals true. Huh, that's interesting. Let's try banana real quick. Make sure that's working. So we're going to copy, Control C, Control V, hit enter. Okay, so it did find banana. Let's do one more. So you see this last one, found is false. Word soup. And let's see where soup is. 6, 0. 5, so it's definitely going, so it's right here. SOUP. There could be bugs in your program. I mean, definitely want to try to work them out as much as you can, and I will as well. So let me copy that, put that in here, hit enter, and then let's go up to soup. Okay, yeah, so it's working. Not sure what happened the first time, so I definitely put that into my bug that it looks like the first two entries either it didn't take or I didn't see it. I need to uh, look a little closer. So that's the way it's working. And then once somebody finds them all, it'll print out a little message. So I'm not going to go through all of them, but you do see how it works. It has a coordinate related to the grid. You have to put in the whole entire word. You can't put in just one letter. You have to put in a whole word at a time, one word at a time. You can't try to put in two words at a time. So one word at a time, the entire word. It most likely has to go in order. We'll see if it can take the words out of order. I believe it can. So that's something else we should test for. Okay. So let's move back to the code. Go over the code a little bit. And I'm going to go to GitHub. All right, here we go. So something I'm going to add in is I don't have a lot of comments. I need to put in way more comments than I have going on right now. So we'll fix that. I will put the word and the board class in separate classes, and then I'll go ahead and create a UML diagram for you to see. Not going to go over every nook and cranny of the board, but we'll go over your word just so you get an idea. Okay. So I believe if you're doing the what do you call it, the Minesweeper, each cell is pretty much a class in itself because each cell is either a bomb, adjacent to a bomb, or not adjacent to anything, right? Because those three kinds of cells you have in Minesweeper. So Minesweeper, you have a grid. So there's a lot of board games that are grid games. So not every board game is a grid game. Like Monopoly. Monopoly sorta is a grid game if you think about it, because Monopoly you're using the outside of the board as the spaces that you move around to the board. So in a way, there are a lot of board games that are grids, but they might not use the entire grid, or they might not go, how would you say, in a linear type fashion, up and down, left and right. But we can think of board games that do use the entire grid, such as chess, checkers, I believe Chinese checkers as well. But continuing, okay, so I have a word class, I have a board class. Might think about to see if I need another class. I'm probably going to create a game controller class that's going to control the entire game, and so that's going to be something that'll be reusable for all games when you have that game controller. And the game controller is going to be real simple. It's just going to, well, do what the main function is doing, which is just starting the game, looping around, calling the game, and then if the game ends, it will quit. So if the game end comes from within the board class, it'll send a message and say, "Don't want to play anymore. I'm done," and then it'll end. Okay. And so all main really should do is just call the game controller, and then that's it. And maybe take on some arguments and pass arguments to the game controller, but main should not really be doing any work. So that's one thing I will fix. Okay. Let's look at the word class. Real simple. So my word class has an X coordinate and a Y coordinate. That's where the starting position of the word will be. Orientation is whether it's going top to bottom, bottom to top, left to right, right to left, rising diagonal or falling diagonal. Okay. And then the word itself, the set of characters itself, and then whether or not that word has been found is important, right? Because once you find a word, you want to know that you found all the words, and then the game is over, and then you can choose whether or not to start another game or in the other, or start another game or in the game. Another another improvement I'm going to make on this, obviously with the comments, yes, comments. Another improvement I'm going to make will be to add more words. I'm going to increase the list size. Okay. And then this is just debug information. So I'll probably have a global variable that says if it's in debug mode, print out debugging information. Okay. And then a little bit of the board class. I'm not going to go entirely over the board class because this case, if this is somebody's homework, don't want them trying to just copy the code and do everything. Okay, but let's go over this. So I did have some comments in the board. The board class will not prevent dictionary words that are not a part of the purposely hidden words to appear. So that basically that just means, let's say if the word apple, the word car, okay, let's say the word car shows up on the board, but it's not a part of the search words, right? Meaning it's truly random. I'm just throwing in once I figure out where the main words are, I'm just going to throw in the alphabet randomly. So a new word might show up in the randomness of the letters that are appearing on the board, but it may not be a search word. But that's fine because this right here records what are the search words. So if it's not, just check your word list. Okay. All right. There I have my algorithm in detail. Not going to read that. Okay, let's just probably stop right here, but let's go through the, oops. Stop right here and go through this. So I have a list of words on my board, right? That's obviously a list of words. Okay. Num orientation. Okay, so that is setting the number of possible of orientations because once I get a word, once I find a word, I'm going to randomly start it at an orientation and try to put it on the board. So the first time I get a word, I might try to put it the regular way we read left to right. If that doesn't fit, I might try right to left, but I'm going to randomly start in all the possible orientations. Okay, there's my list of dictionary words. Okay, not to be confused with the search word list. I have the list of possible words that will go on the board, and then the actual list of words that got on the board, right? Those are two different lists. And with that, you already saw in the word function, once that word gets on the board, it gets a location. Once that word gets on the board, it gets a coordinate, it gets an orientation, and then it determines whether or not it's been found. Okay. Then I have myself a little note that I need to fix. And then I have the actual matrix of the board itself. So the board matrix is going to be n by n. Now, If you have a word search book, it's probably more N by M, where the rows are larger than the columns, so N would be greater than M. Just because that's the way the book, most of our books are rectangles and not squares. Yes, I know square is a rectangle by mathematical definition. Square is a rectangle where both the length and the height are equal. Yes, thank you. I know the definition. But your books are usually elongated where it's a rectangle and not a perfect square. And therefore, you usually have your word searches or your crossword. And this is not a crossword, but your word searches or your crossword might be in the same shape of the book that it's in. Okay. And most of them are in rectangular shape and not square shapes. And we could also do this, and you could come up with a circular word search if you wanted to. Okay, that'd be creative. You can come up with a star shape. So a word search can be any shape you want. It's just a whole lot easier when it's in the form of a rectangle. So I believe I'm going to stop right there. Not going to give away too much code for the board and how I put things on there, just because this might be a project one day. So I don't want everybody just copying code and not using that brain of theirs. So we'll stop here. Thank you for watching, and we will clean this up and make it better. Have a wonderful day.